Ladies and gentlemen, moving ahead with the next speaker, we would now like to invite Ms. Vivek Komaragiri, Chief Technology Officer, Industrial Physics. Specmetrix topic introducing Specmetrix Coil coating technology. Vivek is the Principal Technologist at Industrial Physics and has been Chief Technology Officer at Specmetrix, now part of Global Packaging, Product and Coating Test and Measurement Company, Industrial Physics. With over 20 years experience in the field of advanced and innovative coating thickness measurement techniques, Vivek has utilized his skills to develop patented and award-winning Specmetrix ROI technologies. Can we please have a round of applause for him?
Industrial physics. Today I'm excited to talk about real-time coating and paint thickness measurement. I'll go into details of how that measurement is done, what kind of process improvements you can achieve using a measurement system like that, and eventually it will help in the process digitalization efforts as well. So one of the most important things about the Specmetrix technology is its precision. It's high level of precision, which is significantly better than any other DFT measurement tools that are out there. If you have high precision, that means it brings high level of certainty in whatever you're trying to do. And this technology will help you get that high precision and thereby resulting in significant cost savings. I will go through some details on what kind of cost can be saved. And also minimize waste or result in waste reduction. So this is a brief summary of the Specmetrix. The brand itself, it is based in US. It's been in business for about 20 years. It is an optical, primarily an optical technology, and they're not only coil coating, we are in other markets such as metal packaging, film packaging, aerospace, medical, and a wide range of other industries that apply coating and that have a need for in-process measurement. There are about 800 plus systems over the field. Coil coating is somewhat relatively new. For us, it's been maybe 5 or 6 years. But because of the benefits the technology brings to the coil coaters, it has been rapidly expanding, and we have about more than 70 coil coaters globally that are already using the systems. There are a lot of coil coating line suppliers who are including Specmetrix as part of their lines. So if there is a new line being installed, usually the Specmetrix is offered as an option as well. And you can see multiple names of different coil coaters over there at the bottom of the list, and they are displaced globally. I will name a few of those. Pre-coat metals in US, one of the first ones to embrace the technology 5 years back. They have it installed in all their 17 lines. We have Tata Steel in different locations, France, UK, and so ArcelorMittal in Poland. And this is a snapshot of different coil coaters see across the globe, both in steel and aluminum. So primarily measuring, it's either the wet pre-treatment or the thickness of the primer or thickness of the finished coat and clear coat and so on. India has been more recent for the past couple of years. We first tried to establish a support and service network here before we entered into this market, and APL Apollo was one of the first ones to embrace the technology. They have a product that they are using now, and we are honored to have both JSW and Tata BlueScope more recently for inline measurement. These systems will be, one of the systems is actually being installed right now, and the others will be installed in the next couple of months as well. So I'll go through the details about the technology itself. The technology is primarily optical. It is non-contact, non-destructive. It is non-nuclear, and it is a high-speed measurement. It takes about 100 measurements per second, and the line speed is not a concern. The technology has been tested up to 600 meters per minute. So for coil coatings, that typically runs around 200. The line speed is not a problem. But the way the science works behind the technology is, if you look at this image on the slide, if you have a simple example of coating on top of a substrate, we eliminate the light. Part of the light reflects from the top of the coating or paint, Part of it goes through the coating and reflects on the substrate. So these two ways they interfere, and the resultant wave has a frequency corresponding to coating thickness. So as soon as the coating thickness changes, you will see a change in the frequency of the wave. So the fundamental advantage here is it is an absolute thickness measurement. You don't have to calibrate or teach the instrument to get a thickness measurement. It will tell you exactly what is the absolute thickness of the coating or paint that is being measured. And the fact that the light wave is reflecting from the top of the substrate, the technology is generally substrate independent. Well, that means you could have a paint on aluminum, steel, galvanum, any type of substrate, glass, plastic. It does not matter because the light is bouncing off on top of the substrate. And it can measure both wet and dry. So the system does not care whether the layer of material is wet or dry. It will measure whatever is the thickness of the layer. Obviously, the wet is thicker than the dry, but we have coil coaters using both DFT and WFT systems in line. Some are just using WFT, and they can use the solids volume numbers to predict what the dry thickness is going to be based on the wet thickness. You can measure both clear and opaque coatings because of the wide wavelength of range of light we use. We can measure both clear and opaque, which helps us measure not only clear coatings but paint. And as I mentioned, it is non-contact and non-destructive and non-nuclear. When it comes to the measurement range, I will start with the ROI technology, which is, if it's a paint, it's 1 to 20 microns. If it's a transparent coating, you can measure up to 250 microns. So when we first started doing the coil coating, this was primarily on clear coatings for beverage ends. That is how we started doing that. And that is when on the architectural side, there was a lot of interest from different coil coaters. They said, if you could have a similar technology, but to measure the paints, especially the finished coats, that would be like the holy grail for the coil coating. That is when we took a couple of years of research to develop what is known as EXR technology that we see at the bottom there. It works on similar science, similar principle, but more powerful optics. What that basically does is it helps us expand the measurement range from 20 microns to about 75 microns for paint. So that will cover pretty much the entire, the thickness of paints that you apply in coil coating, except for exceptions like plastisol. Most of the rest of those come within that 75 micron range, enabling us to measure different types of primers and top coats. It is also not dependent on the chemistry of the paint. You don't have to calibrate or teach for each paint. You can measure hundreds of paints with one recipe or 1 second. So it's not dependent on whether it's polyester or PVDF or any type of paint. As long as the light can penetrate through the paint, which it does because of the wavelength we use, it can measure different types of paints and different colors of paints as well. When it comes to transparent, again, the range is much higher, up to 250 or 350 microns, depending on how thick the layer is. So these are some of the benefits and of real-time measurement. The main one is reduced paint waste. So the tendency generally, if you don't have a system that is monitoring the amount of paint that you're applying real time, the tendency is to generally over-apply, just to be on the safe side, because you don't want to be, you don't want the coil to go under-applied. So when you have a system like this, measuring real time, giving real time feedback, you have the ability to control it properly and apply at the minimum end of the specification, and that would result in a significant savings in the paint costs. And you can also eliminate the chances of under-applying coating, so that you don't have to have any kind of material waste. Overall, the quality can be improved. What that does is it results in having less claims from the end customer. There are also benefits if you reduce the paint thickness to a minimum level. Then you have benefits in terms of the solvent evaporation and so on. And the fact that you get results real time, as soon as the material comes under the probes, within the first couple of seconds you will have the first reading. So what that does is you don't have to go to the QA lab to get the measurements. You have real time measurements, and that will help reduce the amount of time needed when you're doing changeovers. So overall, increasing the production throughput. And all these combined will result in significant cost savings. And I will go to specific examples of what the customers have seen in terms of cost savings later on in the presentation. So gauge R&R Some of you may be familiar with it, some of you may be not. It stands for gauge, repeatability, and reproducibility. So any measurement gauge, the gauge R&R is an important factor. If you have 3 operators taking a measurement on the same sample, what you ideally want is all 3 of them getting the same result. If you have that consistency, then you can use that consistency to optimize the process. But if you look at the bottom of the slide, those are all the legacy tools that are used in the coil coating right now, and they don't have very good gauge R&R. So in that case, if 3 people take measurements, they all get 3 different results. That means there is measurement variability. And if you have measurement variability coming from the gauge, you cannot really optimize your process because there is variation coming from the gauge itself. So in short, any gauge R&R less than 10% is considered excellent, and with Specmetrix, it's about usually less than 5%. So it's a very high gauge R&R. And NCCA, if you're familiar with that, it's a National Coil Coating Association in the US. They have done an extensive study called ILS, and the result of that is the precision of Specmetrix is 5 times better than the nearest gauge that is used in the coil coating. There is also an ASTM standard, ASTM D8331, that gives you details about all the precision and statistics related to the test that they have done. This is another slide showing the same principle. This is done by Sherwin-Williams, who are a leading paint supplier in the US. They have studied the technology over a period of several months and compared with the existing tools that are out there. So what you're seeing here is basically the tube, Fisher scope, and DJH. Those are the ones that are being currently used in coil. The tube gauge takes about 300% of the tolerance. The variation from the gauge takes about 300% of the tolerance. So you can never use that gauge to make sure you are within specification. Fisher scope and DJH take about 100% of the tolerance, whereas if you take Specmetrix, it only takes about 17% tolerance. So this is all showing the variability of the measurements coming from the gauge. And this can be captured even better in the next slide. So this is the coating tolerance. So when you're trying to apply a finish coat or a top coat, for example, the specification is generally 0.7 to 0.8 mils. This is the unit used in the US, so it typically translates to 17 to 20 microns. So you're trying to apply your finish coating in that range. And if you use a DJH or a Fisher scope, for example, that the variation from the gauge will take up the entire tolerance. So you can tell whether you are in tolerance using those gauges, but you cannot really optimize it any further because the variation is taking up the entire tolerance. Whereas if you look at with Specmetrix, it only takes a small portion of the tolerance, so now you have the ability to apply the coating, or you measure it here, get better control, then you shift to the left and you apply towards the lower end of the specification. That in itself would give you 5 to 10% reduction in the paint usage, thereby resulting in paint cost savings as well. So this, some of you may be familiar with the drill gauge. This is how it is done in many coil coating plants right now, how they measure the thickness of the paint. They run the coil, they take a small piece of sample, they go take to the QA lab, drill it and measure it to the DJH. So let's say it's 0.97 mils, then they assume, okay, the rest of the coil has that thickness, and they run the rest of the coil with that. But what happens instead of taking a measurement there, if you take a measurement just few centimeters away, with the same gauge, same operator, everything remaining the same, now the result is 0.88 mils. So suddenly there is a 10% difference in coating. So depending on where you measure at the beginning, whether you measure in the second spot or the first spot, you're expecting the rest of the coil to be that way. So if you take the 10 measurements, each of those 10 individual measurements are different. So there is a lot of variation coming from where you're taking measurement on one given sample. Even if you ignore the fact that whatever measurement you take is not representative of the rest of the coil, even there you see a 10% variation. So what if you take multiple samples, not just one paint, or if you take 3 different samples? So this here is the data on 3 different samples. This is not done by us, this is done by a third party, but you can see 10 measurements on each of those. There is about a 10% variation using the drill method. If you look at the bottom table, which is Specmetrix, you can see the variation is now down to 1%. So now you can measure and control within 1%. That gives a lot of flexibility for you to adjust and optimize the coding process. What you also see here is the average of the 10 drill measurements comes pretty close to Specmetrix measurement. But you have to do an average of 10 measurements, and with the drill, as you probably know, each one could take up to 5 minutes. So if you really want a good measurement using a drill gauge, you want 10 measurements, take an average that gives you a true picture. Whereas with Specmetrix, you take about 100 measurements per second, you quickly scan the sample for a few seconds, it will give you a very good average of hundreds of measurements and making it very repeatable. So the different product configurations that are offered, especially for coil coding, is very simple. You can either have an offline system. On the far left is your offline system. You have a primer probe and a finish probe, and whether the operator is measuring a primer or finish, you can use the appropriate probe to do that. Here you have a fixed probe system where you have 3 different probes, left, center, and right. You get 100% results on those 3 different positions. So it really depends on the customer's choice, whether they want 100% inspection on specific locations or whether they want crossword and downward profile. And the last configuration you see there is, this is a traversing unit where it comes in, it detects the edge, goes to the other side, detects the edge on the other side, and it just keeps measuring across the width of the coil, and the software will provide both the downward and the crossword information. And when you change the coil widths, it will automatically detect the width and stay within that. So you don't have to make any new adjustments to the system when you change your coil width. The other advantage there is when there is a splice coming. The sensor is about 25 millimeters from the strip. So if you have a splice coming through, especially if it's a flat splice, you can provide a signal in advance and the system will go in park in the home position so that there is no chance of hitting the sensor. And the bottom are the software screens. This is offline measurement. The fixed probe, you have left, center, and right. You have continuous readouts in all these 3 locations. Every second, there is a new reading. And you will see the trend displayed here. This is the specification. As soon as the coding goes above or below the specification, you will see that green or blue indicating that, indicating the operator that it's out of specification. They quickly need to take action and change to bring it back into specification. Similarly, on the traversing system, you can divide the coil width into multiple different lanes, and you can see how the coding is distributed across the width of the coil. What you see here on the top image is towards the edges, there is low coding, and you will quickly see that with high resolution data, and you will be able to control using a real-time system. This is a short 2-minute video that shows you how the system works actually in a coil coding plant, and I will explain along the way as well. So that just gives you a quick idea as to how the systems work in a typical color coding line. So now I just want to quickly share some of the case studies of what the customers have seen once they started implementing this in-process measurement technology. So there are a wide range of cost savings that can be had using Specmetrix technology. The major one is obviously the paint savings, which is one of the most expensive components of coil coding. And there is a possibility that if you're using a test strip, mainly to see, like a test shot, to see the initial setup, you don't have to do that anymore when you use Specmetrix, because you get results within the first few seconds, so there is no real need of a test strip. And there are customers who were able to eliminate the test strips, and that resulted in a lot of savings. Because of the quick feedback, there are savings in the labor hours as well, and also overall increase in production throughput. And the system gives you a unique combination of benefits. It not only helps with the cost reduction, it will also help improve the quality. And that is a very rare combination. Normally you can either reduce your cost or improve your quality, but not both. In this case, you'll be able to reduce the cost and also improve the quality by making sure that the paint coating is not only applied in specification, but it's uniform and consistent across the width of the coil. And what that does in the end is it will help you produce a quality coil, and it will reduce the claims coming back from the end customer. So these are different plant impacts. Having a real-time measurement tool such as Specmetrix. I'm not going to read all of those to use. Several of those are pretty obvious, but cost reduction, improved coding line utilization. In most cases, the measurements readout screens are in the code room, so that the operator can quickly see whenever he's setting up or doing a changeover, he can immediately make changes and bring it right in the specification very quickly. One of the first coil coders in the US to use the inline measurement system, they were able to save about $1 million just in paint costs in the first year, and that results in a very quick ROI for the system. A couple of other examples. There was a customer who was able to get 1 month of additional production time because of the production efficiency benefits, and there was another customer who saw like 68% reduction in scrap. So all this is customer data that was provided to us. So this is a company in Europe called Euromax. You may or may not be familiar with them, but one of the few companies who allowed us to use their name. This is their data. This is what they shared after using Specmetrix. So what you see here is the blue and the orange are the gauges they were using. And you can see the variation coming from those gauges. It's pretty significant. So once they started using Specmetrix, they saw a very low standard deviation in their measurements. So you can see the precision gives them very repeatable readings, and they got a gauge R&R of less than 1%, and they were able to control their process much better using the results from Specmetrix compared to what they were doing before. And the standard deviation was 6 times better. And they say first time right, which means they see the feedback immediately and they make sure the right amount of paint is applied from the very beginning. This is a more recent example. These systems were installed just about 6 months ago in US, Coil coder named Ringstamp. So what they have done is they have installed both wet systems for WFT and dry systems for DFT inline measurement. And what you see here is you see the two probes, the light beams. So that is the area it's measuring, but it takes about 100 measurements per second, so you get a very good average as the coil is going through. So there's one on the left, one on the right, and before this they were using the wet film wheel, and as you know, it doesn't have the resolution to give you very precise thickness if it's a wet film wheel, and it will also leave polygonal marks on the strip. And this is pretty common once the coil coders start using the systems and start getting the amount of data they get. They will start seeing some things that they did not even realize in their process. So the data will give them new insights. The same thing happened with this customer. They were able to see many things that were happening in the process that they did not know before because they didn't have the data to make that analysis. Now they have the data, they're learning more about their process, and then they're making it more and more efficient. Obviously, the coder operators, they immediately adjust, and as I mentioned, the more data they have, the more visibility they have into their process, and the more chances they have to optimize. So this is on the wet film side. The next is the dry film. Again, these are two probes, one on the left, one on the right, measuring continuously on those two locations. They currently, before Specmetrix, they have to wait for the measurements to come from the QC lab. They no longer need to do that because it's real time, so they are saving some time over there. And the next step they're taking is a closed loop control, which seems to be the goal of most of the coil coders that are currently using Specmetrix systems for real-time monitoring, is to eventually close the loop, get the direct feedback, make the automatic adjustments so that the operator doesn't need to do more. But depending on the age of the line, the sophistication of the line, for some it's quick, for some they have to upgrade the line to make that closed loop control possible. But the Specmetrix system itself will provide all the data necessary in real time to be able to do that closed loop control. So this particular company, for instance, that's an active project. There are multiple other coil coders who have already finished the closed loop, but in this case, they're also looking at viscosity control, especially measuring wet. They make sure the viscosity is set correctly, so they use clear systems to monitor the viscosity. And Specmetrix for thickness measurement, they use combined both to do the closed loop function. This just relates to the elimination of pest strips. In this case, resulted in about 600K savings for this customer. But this is more important. This is a case study for one of the coil coders in the US, and that may not be representative for all the coil coders, depending on the variables that they have. But in this case, in this particular plant, there is about $30 million of paint per year, and they were able to save 5% on the paint costs. That itself resulted in about $1.5 million in savings. So they had $0.6 million from eliminating test strips. They were able to avoid some claims and other savings included. Overall, the savings were about $2.4 million in the first year, and the ROI over there is 2 months. So it's a very quick, very attractive ROI. It need not be the same case with all the other coil lines out there, but even if it's 4 months instead of 2 months or 6 months, it's still very quick and attractive. So more like a summary, plant digitalization is something that many are considering, and it begins at process automation. And the labor shortage may not be a big issue here, but globally it's been a big issue. That is where most we started looking at process automation. But to do the process automation effectively, you need precise data. If your data is not of high quality, then you're not able to automate the process as effectively. And the continuous data that is provided by the systems, it helps process improvements. Different types of coatings can be measured. It could be wet pre-treatments. Starting from there, we can measure it in the wet. And dry smoothing, but in wet can be measured. The primer, the finish coat, the back coat. If you apply clear coat on top of it, the system can measure the clear coat. If you put a laminate protecting the coil, the thickness of the laminate can be measured as well. So that's pretty much the summary of what the technology has to offer, and will be all of this to be available for any questions.
Thank you very much. Can you please have a round of applause very firstly for you? Do you have any questions coming from the audience? We are now open for Q&A. Yeah, I see a hand there. So please introduce yourself and your company name also.
Hi, this is Neeraj. I'm from Data City. So I had a couple of questions here. So, do you have any references in India? Any references in India? The system, customer?
Yeah. We have years now. So APL was the first company to get in coil coating, but we have on the other side Avery Dennison in film packaging, Massey in metal packaging. More recent ones are systems we have delivered are from GSW, both in Tarapur and Pasin and Tata Pusco. Those systems are yet to be installed, but they were purchased recently.
One more question is, there will be some variability in the system. Maybe there could be because of temperature, maybe because of humidity, vibrations, dust. So how your system is getting calibrated, what accuracy level it will deliver with all these variabilities?
Yeah, a great question. So when we first started, it was an offline measurement like most optical tools, but we realized inline is where the real action is. So we did 2 to 3 years of research, mainly to compensate for all the different variables that we see in production, the flutter, the temperature, the humidity, all of those are adjusted automatically. So we say offline the measurement accuracy is plus or minus 1% of the applied coating thickness. The same technology is used in line, but in line we specify plus or minus 3%. Because it's hard to compare an inline measurement to an offline tool. There's always some variation there. But the technology itself is same both offline and inline. The accuracy is equally same, but the specifications are separate.
And one last question I have: do you have any AI inbuilt in it or any analytics you offer?
Yeah, we as of right now we don't offer any of that because that was not needed. But we are looking into. We use something called recipes. They're a one-time setup, but they're set up by someone who's familiar with how the system works. So that is where we are looking into including some AI so that the user doesn't have to interpret the data. It will all be done automatically.
Thank you. Hope it is maintenance friendly.
Thank you.
Thank you very much. Any more questions? Looks like that is it. Thank you so much, sir. We really appreciate your presence.